Hey guys, welcome to another online math class. This video will be about tree diagrams. And by the end of this lesson, our goal is to know the key features of a tree diagram, be able to create one, and also use one to find the probability. Alright, let's just pause the video here and take a couple of minutes to write these down. Alright, so starting off with what a tree diagram is. A tree diagram allows us to see the outcomes in an experiment, and it uses branches to show the possible outcomes of each trial. So this is what a tree diagram looks like on the left here. You guys might have seen this before. And each of these blue lines there, these are called the branches. And each section in a tree diagram represents one trial. So we can see here, that's one section there, and that's another section there. And as you can see in this next image in red there, that red part just represents our first trial. So in this case, we're flipping a coin. It's going to give you either heads or tails. That's our first coin toss there. So in our first coin toss, we can either get a heads or a tails. The next part shows our second trial. So in blue there, that's our second trial. So once you flip the coin once, if you flip it again, you're still only going to get either heads or tails. And at the end of the experiment, we display all the possible outcomes. And we can do that by following the paths in a tree diagram. So if you look here, that's an example of one path in orange there. One possibility is to flip heads the first time and then flip heads again. And your outcome for that case will be heads and heads. We got that by following that and then there. Our next path, I'm just going to draw that in. It could be heads first time and then tails next. So our next outcome would be heads and then tails. You could also get tails first and then heads. That becomes tails, heads. And then you could get tails and tails shown there. And each of these parts here, just at the end, so one of those, they represent an outcome. So there's a total of 1, 2, 3, 4 outcomes as shown there. First one's heads, heads, and then heads, tails, tails, heads, and tails, tails. They're all our possibilities. Alright, let's have a look at this example here. It says, on any given day in Jesse's town, there is an equal probability that it will be sunny, cloudy, or rainy. 2 days in a row, Jesse records the weather, then puts the information into a tree diagram. Alright, so on any given day, it could be either sunny, cloudy, or rainy, which is why we have S, C, and R there. And then second day, same scenario. And let's write out all the possible outcomes. So it could be sunny first day and then sunny the next, just following that path there. So it should be SS and then it'll be SC, just following the next path. And then SR, sunny and then rainy. It could be cloudy first and then sunny. Just keep following the paths there. And last one will be CR. And this one will be RS. So these are all our possible outcomes. RC and then RR. And then we'll count them up. There's a total of 1, 2, 3, 4, 5, 6, 7, 8, and 9. So your answer for this part will be there are 9 possible outcomes in total. So that's how to find the total number of outcomes. Let's have a go at using tree diagrams to find probabilities. Alright, now back to the coin toss example. In our first trial, when I flip a coin, I'm either going to get heads or tails. So probability of getting a heads is 1/2 and tails is also 1/2. In my second trial too, from my heads, I'm either going to get another heads or another tails. It's going to be 50-50 again. And same here. No matter what, it's either going to be heads or a tails. So to find the final probability of each one here, that one, that one, that one, and that one, all you need to do is multiply along the path here. So if you go follow this path here, it's going to have a half and a half there. So to find that probability, it's going to be 1/2 times 1/2, and 1 times 1 is 1, 2 times 2 is 4, so that's going to be 1/4. Same for the next one, just follow the path again. It's still going to be 1/2 times 1/2, which gives me 1/4, and it's going to be the same for each of these. So this one's also 1/4, and that one is also 1/4. So if you had a question like, what is the probability of getting a tails heads, we would know that it is 1/4. Now let's have a go at putting this all together. So we have this problem here. Boxes A and B contain 4 counters each. Box A contains 2 red and 2 green, and box B contains 1 red and 3 green. A box is chosen at random and then a single counter is selected. Alright, so we've got a total of 2 boxes, box A and box B. It says a box is chosen at random. Our 2 options are A and B, and they both have an equal chance of being selected, so they're both going to be probability of 1/2. Next one, box A contains 2 red and 2 green, so you can only pick either red or green. And they both have a 50-50 chance because red, probability of red here, Let's write that again. Probability of red is 2 out of 4, which is 1/2. Probability of green is also 2 out of 4, which equals 1/2. So let's just write that in there. So I'm going to call red R and green as G. Probability of getting a red is half and green is also a half. But if you picked box B, let's have a look there. It's also red and green, but for red, it's 1 out of 4. There's only 1 red and 3 green. So probability of getting red here will be 1 out of 4, and probability of getting green will be 3 out of 4. You're more likely to get green than red. Alright, so that's our tree diagram there. And let's fill this out. So the outcome here, we need to write out the outcomes. First one's AR, just following the path. Next one's AG. This one is BR. And this last one is BG. We also need one last part here, and that's the probabilities. We did that by multiplying along the path. So this first one will be half times 1/2, which equals 1/4. This one will also be half times half. I'm going through there and then there. So that's half times 1/2, which also equals 1/4. In this case, it's a bit different. That's half times 1/4. That gives you 1/8. And this next one will be half times 3/4, which gives you 3/8. Alright, let's have a go at doing the questions. I've actually done question C first. That is question C. This represents as a tree diagram. Let's have a go at question A here. If box A is chosen, what is the probability that a red counter is chosen from it? So we did this at the start. Probability of getting red is 2 out of 4, which equals 1/2. And let's do B as well. B, if box B is chosen, what is the probability that a red counter is chosen from it? So if we pick B, there's 1 red out of the 4 counters, because there's 3 green, so it's going to be 1 out of 4 there. Jumping to question D now, because we've already done C. What is the probability of selecting box B and a red counter? So if you've got a tree diagram, this is pretty easy. Just go follow box B, follow that path, and then red. So we're looking at BR there, and our probability is 1/8. So probability of BR equals 1/8. And last one, what is the probability of selecting a red counter? So in this case, it doesn't matter which box you pick as long as there's a red. So let's have a look. There's a red in this one and in that one. So all you need to do here is add these two probabilities together. That one there and that one there. So that's going to equal 1/4 plus 1/8. And make sure the denominators are the same when you're adding. Let me know if you struggle with adding fractions, and that'll be 3/8. Alright, let me know if you do have any questions up to this point. Otherwise, you can move on to the next one. Have a go at these ones by yourself and just unpause the video when you're done with these. Alright, so let's do this in order this time with question A. It says boxes A and B contain 5 counters each. Box A contains 3 red and 2 green, and box B contains 1 red and 4 green. So it's very similar to the one we just did. A box is chosen at random, and then a single counter is selected. If box A is chosen, what is the probability that a red counter is chosen from it? So in box A, there's total 5 counters, and 3 of them are red. So probability of red, that's going to be 3 out of 5 there. Let's go to question B as well. If box B is chosen, what is the probability that a red counter is chosen from it? So probability of red again. So this time there's 1 out of the total 5. So that's going to be probability of 1 out of 5. Give yourself a tick for each one you got correct there. Now question C, I'm going to do that here because there's a bit more space. It says represent the options as a tree diagram. So once again, we have box A first, and then we got box B. And there's an equal chance of selecting both, so it's going to be half and half. Next one, we're picking the counters. So there's red and there's green. Same with this box, there's red and there's green. The probability of picking a red here is 3 out of 5 because there's 3 red and 2 green, and the green is going to be 2 out of 5. For this next box, red is going to be 1 out of 5 because there's 1 red and 4 green, and green is going to be 4 out of 5. Now let's write out our outcomes. AR, AG, BR, and BG. And the probabilities on the very right here, that's just going to be half times 3/5. That gives me 3 over 10. This one's going to be half times 2 over 5, which gives me 2 out of 10, which gives me 1 out of 5. Make sure you're simplifying. This one becomes half times 1 over 5, which becomes 1 over 10. And this last one becomes half times 4 over 5, which becomes 4 out of 10, which is 2 out of 5. Make sure you're simplifying again. Give yourself a tick if you got this tree diagram correct. And question D. What is the probability of selecting box B and a red counter? So it has to be BR, that one there, and we know our probability is going to be 1 over 10. And question E, what is the probability of selecting a red counter? So I need to add all the possible red ones together. So that's this one and that one. That's going to be 3 out of 10 plus 1 out of 10, which gives me 4 out of 10. Make sure you simplify, divide both the top and the bottom by 2. That gives me final probability of 2 out of 5. Give yourself a tick if you got that correct as well. Alright, so this was all with replacement, if you guys remember what that means. Let's have a go at doing that without replacement now. So recap from last lesson, without replacement is, let's say if I pick a blue marble here, it means I don't put the blue marble back on my next pick. It's just I keep going with whatever's left in the selection. So let's have a go at doing this. Question A first, drawing a tree diagram. So a bag contains 5 blue and 3 white marbles. So there's a possibility I'll start with blue up the top. So we can pick either blue marbles or white marbles. And there's a total of 8 marbles because 5 plus 3 is 8. So it's going to be out of 8. That's going to be out of 8. And there's 5 blue, so it's going to be 5 out of 8. And there's 3 white, so that's going to be 3 out of 8. Alright, now moving on. I'm going to pick another marble. So possibilities are still blue and white. That doesn't change there. But if I pick a blue marble, that means there's going to be 1 less marble from the total. Because there's a total of 8. If I picked 1, there's now going to be 7 left. And if I picked 1 blue, that means there's going to be 1 less blue left in the selection. So that means there's going to be a total of 4 out of 7 left. And if I picked a blue at the start, the number of white doesn't change. There's still going to be 3 white marbles left in there. But once again, the total is going to drop down to 7. Because initially we had a total of 8 marbles. If I take 1, there's going to be 7 left. And moving on to the next one. If I pick a white marble first, I'm still either going to pick a blue or a white marble next. But this time, number of blue is going to stay the same. Because I picked white first, there's still going to be 5 blue left. But the total is going to drop to 7 again. And in this case, there was a total of 3 to start off with. If I pick 1 white, there's going to be 1 less white left in there. So there's going to be 2 and the total is going to be 7. That's what your tree diagram should look so far. I'll just fix up that 5 there so it looks a bit better. And now we're going to write out our outcomes. That's blue, blue, that's blue, white, that's going to be white, blue, and that's going to be white, white. And to find the probabilities, same thing. Just follow the path and multiply the fractions. It's going to be 5 over 8 times 4 over 7. This one's going to be 5 over 8 times 3 over 7. This one's going to be 3 over 8 times 5 over 7, and this one's going to be 3 over 8 times 2 over 7. And once you work that all out, these are what your answers will be. This first one will be 5 over 14, that one will be 15 over 56, that will be 15 over 56 as well, and this one will be 3 over 28. There's nothing we can simplify in these. Alright, let's have a go at question B, part 1. Let's find the probability of selecting a blue marble followed by a white marble. So that's what it should look like. That's right there. So we know our probability is going to be 15 over 56. Next one, part 2. 2 blue marbles. That's B, B there. So we know probability of B, B equals 5 over 14 there. And next one, exactly 1 blue marble. So we only want exactly 1. So there's 1 blue here and 1 blue there. This one doesn't count because there's more than 1 blue. So for part 3, it's going to be 15 over 56 plus 15 over 56. That gives you a fraction of 30, or probability of 30 over 56. When simplified, becomes 15 over 28. Alright, don't worry about question C. Let's move on to the next one. Pause the video here, have a go at this one by yourself, and just unpause it when you're ready to go through it with me. Alright, let's start off by drawing out the tree diagram again. So it's going to be blue and white again. And the probability of picking a blue first is going to be 4 out of 9, because there's 4 blue and 5 white, so there's a total of 9. And the next one is going to be this total of 5 whites, it's going to be 5 out of 9. Alright, next one. So this is without replacement. So we're not putting the blue marble back or the white marble back. So this one has to be 3 out of 8. This one has to be 5 out of 8. I should have wrote blue and white there. And this next one, this one will be 4 out of 8. And this one will be 4 out of 8 as well. And if I simplify these, make sure you simplify them. 4 out of 8 is the same as a half. And this one's the same as a half as well. Give yourself a tick if you got up to here correct so far. Alright, so next we're going to write out the outcomes. Let's go back. So the first one will be BB, blue, blue. This one's BW. This one's WB. And this one's WW. And let's work out the probabilities. This one will be 4 out of 9 times 3 over 8. This one will be 4 over 9 times 5 over 8. This one will be 5 over 9 times a half. And this one will be 5 over 9 times a half as well. And let's just work those out. This one becomes 12 over 72. This one becomes 20 over 72. This one becomes 5 out of 18. And this one is also 5 out of 18. And just make sure you're simplifying your fractions. You can divide both the top and the bottom here by 2. So that becomes 6 over 36. You can divide both these by 6 again, so simplify it once more. That becomes 1 over 6. Could just simplify it by 12 there. This one I can divide both of these by 2. So this one becomes 10 over 36. And then I can divide it by 2 again. It becomes 5. 10 divided by 2 is 5 over 18. Alright, now we can do the rest of these questions. B1, a blue marble followed by a white marble, so BW, that's that one there, it'll be 5 out of 18. Part 2, 2 blue marbles, that's that one there, will be 1 out of 6. Part 3, exactly 1 blue marble, so I'm just going to add this one and that one. It'll be 5 out of 18 plus 5 out of 18, which gives me 10 out of 18. Divide both of them by 2, gives me 5 out of 9. Alright, give yourself a tick for each one you got correct there. And good job for getting this far. And for the with replacement question in question C, you'd have to do exactly the same thing, but just have different probabilities there. So only your second trial will change, your first trial will be exactly the same. This will just be 4 out of 9 again. And that will be 5 out of 9, because we're putting it back so our total doesn't change, and we'd still have 4 blue. Same with this one, this would also be 4 out of 9. And this would be 5 out of 9 as well. And the probabilities here would just be different. It will be 4 out of 9 times 4 over 9 for the first one. This one will be 4 out of 9 times 5 over 9. Alright, so that brings us to the end of this video. Hopefully you guys have a better understanding of tree diagrams by now. And that you can, you know the key features of a tree diagram, can create one and can use one to find the probability. Alright, thank you guys for watching, and I'll see you guys all back online.